Hey physics class, I'm making this video because this is a very complicated problem, and whether you need help just getting started and setting up, or whether you've made some progress and don't really know where to go from there, hopefully this will meet you wherever you are. So first thing is, let me set up this problem from start to finish. So remember, we've got this 1 kilometer drive, and at the end of 1,000 meters, we would be done. There is, however, a speed trap that is in this little zone from about 400 meters to 500 meters, and that is where the speed limit of 20 meters per second is strictly enforced. And the limitations on your ability to move, there's a bit more light. Limitations on your ability to move are as follows. You can accelerate anywhere up to and including 3 meters per second squared. You can maintain a constant velocity, and then you can also decelerate. And that would just be the same magnitude of acceleration, just slowing down instead of speeding up. Okay, so you can only change your speed by 3 meters per second squared, either speeding up or slowing down, and if you reach a speed that you like, you can keep it. We're going to be just using all the equations, that distance is equal to half the acceleration times time squared plus an initial velocity times time plus some initial position. We've also got this one, which is 2a, and then I think it was delta x equals v squared minus v0. In your notes, you might have it that it looks like this. X is equal to v squared minus v0 squared over 2a plus x here. Those are the same equation, just solved differently. And then also, let's see, a is delta v over delta t, of course, and v is, I guess I should say average v is delta x over delta t. So these are all the equations that we'll be using in order to try and make this trip in as short a time as possible without exceeding 20 meters per second in that little speed trap. So let me go through the first responsible, law-abiding example that I gave, and that would be that I just get up to the speed limit and then stay there. So first question is, let's just accelerate at a responsible 2 meters per second squared. So if I have an acceleration of 2 meters per second squared, how long will it take until I reach 20 meters, just 20 meters per second, the speed? All right, we're just trying to speed up to the speed limit. So in order to answer that question, we just got to use this equation, a equals delta v over delta t, except we're looking for t. So if we solve for t, we'll be doing change in velocity over a. Since that is what we're looking for, I'm trying to get up to 20 meters per second, and I'm doing it at 2 meters per second squared. That's 10 seconds. Okay, so just starting off, you speed up at an acceleration of 2 meters per second squared. 10 seconds later, we're at the speed limit. How far have we gone? In this particular case, we're going to need to be using this equation because that tells you how far you've gone if you're accelerating and you know the time. Since that's what we know, let's go ahead and use it. x is equal to a over 2 t squared. I don't have an initial velocity. I don't have an initial position because I started at rest at the start. So that's really all I need. The acceleration is 2. The time is 10. 2 over 2 cancels out. 10 squared is 100. So I've gone 100 meters in 10 seconds. There's 10 seconds. Where's my 100 meter mark? I guess about there. So just so we are clear, start off, I accelerate at 2 meters per second squared. It takes me 10 seconds to go 100 meters. And then I'm just going to stay at 20 meters per second the whole rest of the way. I have 900 meters left to go from 100 to 1,000. That's 900 meters. So now I'm going to be using this. Distance is equal to how fast you're going times how long you went. I know that the distance is 900. I know that my speed is 20 meters per second. So that's 900 meters, 20 meters per second. I want to know how long that takes. So simply, it's going to be 900 divided by 20. 900 divided by 20, 45 seconds. So we've got one possible way to do this. Accelerate at a nice responsible 2 meters per second. In 10 seconds, you will have gone 100 meters and you've reached the speed limit, and then you just stay there for another 45 seconds. 10 seconds to speed up to the speed limit, 45 seconds that you remain at the speed limit. This is a total drive of 55 seconds. I'm just going to keep a list of these options. So I'm going to call this option 1, the responsible option. Option 1 is accelerate at 2 meters per second squared until the speed limit and just stay at that the rest of the time. That takes 55 seconds. Okay. Let's be a bit more adventurous. This time, I want to speed up past the speed limit and then slow down to the speed limit, you know, to look good for the cop. And then, once I pass the cop, I'll speed up again. So let me put my marks on here. It's about 400 and about 500. So here's what I'm going to do. I'm going to accelerate as hard as I can here and then slow down, stay at 20, and then I'll just speed up this whole way. I wonder what the top speed of my car is, but I guess it doesn't really matter. Okay, so first thing I'm going to do is I'm going to start accelerating at 3 meters per second squared. I need to decide where I will stop doing that. I think I'm going to do it, I think I'll do it halfway. So I'm going to go all the way up until 200 meters. Okay, so in this region right here, here's 200. I'm going to accelerate right there, 3 meters per second squared. Okay, where do I go from here? the information I have is a distance, an acceleration. Well, if I have a distance and an acceleration, I could either figure out how long it would take or how fast I'm going. I'm going to go with how fast I'm going. So I'm going to use this equation, 2a delta x equals v squared minus v0 squared. Since I'm starting at rest, this is 0. And this is all I have to worry about. 2 times the acceleration, which is 3, the distance, which is 200, and I don't know the speed, but I'm about to get it. Okay, let's work that out. Oh, there it is. My calculator wasn't hidden. Okay then, so I've got 2 times 3 times 200, 1200. 1200 equals v squared. All right, I'll take the square root of 1200, and it is, 34.64. Yeah, that's a problem, because that is speeding. How long did that take? How long did it take to accelerate to that velocity at 3 meters per second squared? Just real quick, I'm going to find that out. How long did that take? Acceleration equals delta v over delta t. I'm looking for a delta t, so that means I could just rearrange that. T equals delta v over a. How long did it take to accelerate to a velocity of 34.64 at an acceleration of 3? Just divide that by 3. Okay, it took 11.5 seconds. Okay. So we are clear. I accelerated at 3 meters per second squared for 11.5 seconds. It got me 200 meters, and I'm now a good 14.64 meters per second over the speed limit, which means I need to slow down. I will be able to slow down. I only need to slow down to 20. So next thing is I need to slow to 20. Okay, well, since I'm really just interested in slowing down to 20, I need to have a final velocity. I have an initial velocity, so I have a change in velocity, and I have to do it in that distance. So if I use this equation again, this time I don't know what the acceleration will be, but I do know that I have 200 meters to drive. This 200 meters, from 200 to 400. I don't know the acceleration. However, the final velocity must be 20 meters per second, and the initial velocity was 34.64. This equation represents me slowing down from the initial velocity of 34.64 to the final velocity of 20 meters per second. I only have 200 meters in which to do it, and I need to know what that acceleration is. Okay, so 2 times 200 is 400, so I got 400a over here. 20 squared is 400. 34.64 squared was 1200. So real quick here, I've got 400a equals 400 minus 1200. That's minus 800. Divide both sides by 400, and my acceleration is -2. Am I able to do an acceleration of -2? Yes. Yes, I am. My limit was -3. I'm able to do that. Awesome. So if I accelerate at, well, I should say decelerate at that rate, how long is this? How long does it take for you to slow down? How much should I slow down? Let's look at the equation. A equals delta v over delta t. I know what my acceleration is. It's -2. What about my delta v? Well, I'm slowing down from 34.64 to 20, which means I'm slowing down a total of 14.64 meters per second. And I don't know the time. So if I just switch those two, my final answer will be -14.64 divided by -2. Delta t equals -14.64 meters per second over -2 meters per second squared. That 14.64 divided by 2 is 7.32 seconds. So we are clear. I accelerated as fast as I could for 200 meters. I got there in 11.5 seconds. I had to slow down to the speed limit. I was able to do that in 7.32 seconds. Now I'm going 20 meters per second through here. That one is going to be the easy one. 20 meters per second. I think I'm going to put up another piece of paper here. 20 meters per second right there. I have a distance to cover of 100 meters. And I just want to know how long it takes. Well, v equals delta x over delta t. The t is going to equal the distance divided by the velocity. So that's going to be 100 over 20. It's 5 seconds. 5 seconds. Okay. Here's the good part. I've got 500 meters in which to just accelerate as fast as I can. So, once again, 2a delta x equals v squared minus v0 squared. My acceleration can be 3. My delta x is going to be 500. I don't know what my final velocity is, but I know my initial velocity is going to be 20. Solving time, 2 times 3 times 500. 2 times 3 times 500. 3,000. 20 squared is 400. Right? Okay, good. Add 400 to both sides. Hey, there's our final velocity. Oops. Holy cow. You should never ever go that speed. But just in case you do, the cop didn't see you. Okay, so final question is how long did that take? So that is speeding up from 20. So we have a delta V of 38.3. And real quick, if you can only go at an acceleration of 3, your delta V is 38.3. Looking for a T. Off camera, T is going to be equal to 38.3 over 3. I have to do this so fast. Thank you, Mr. Dennis, very much. 38.353 is. There you go. That's how long it takes. I finished it just in barely time because it's lunchtime in here. How long did that take? It took you a total of 11.5 seconds plus 7.32 seconds plus 5 seconds plus 12. Hey, 36 seconds, not bad. It's faster than the other one.